future doctors. Welcome back to GCSE AQA Biology by Best Medicine. This is the second video of chapter number 3, diseases. Today we're going to be talking about non-communicable diseases. These are diseases that cannot be transmitted from one person to another. So non-communicable means non-transferable. These are also called non-infectious diseases because pathogens are not involved. Remember, pathogens like bacteria, viruses, fungi, protists, none of them will be involved. So if you cannot get the pathogen from one person to another, you cannot get the disease from one person to another. Now, examples of these diseases include diabetes, which will be covered in the hormonal coordination chapter, coronary heart disease, which we've already covered in the circulatory system chapter, cancer, stroke, and hypertension. Now, cancer is uncontrolled cell division. Stroke is when there is a blockage of blood flow in the brain. And hypertension, hyper means high and tension means stress. So hypertension, high blood pressure, okay? Now, coronary heart disease actually is the leading cause of death throughout the world. This is followed by stroke, COPD, and cancers. COPD is it's referred to as chronic obstructive pulmonary disease. And what it is a disease that is caused by long-term usage of cigarette smoking. Okay? So what are some of the risk factors for non-communicable diseases? Well, before we go into this, I want you to remember that different diseases would have different risk factors, right? So cancers would have different risk factor as compared to coronary heart disease, which would have a different risk factor to COPD, and so on. Even different cancers would have different risk factors from each other. So risk factors for non-communicable diseases. Number one is unhealthy diet. So high intake of processed foods, saturated fats, sugar, low intake of fruits and vegetables. Basically, an unhealthy diet would mean that you have a higher risk factor of developing some kind of disease. Remember, if you have a diet that is rich in cholesterol and lipids, then there is an increased risk of coronary heart disease. Too much sugar can lead to diabetes, and so on. So we have a meme to share this: when all you bought was healthy food and now there's nothing good to eat because all you have is vegetables. Sedentary lifestyle is yet another risk factor. Sedentary lifestyle essentially means lack of physical activity or exercise. So if you're sitting on your sofa and bed all the time, that's called sedentary lifestyle. You're not having any sort of activity. You're not getting that blood rushing in your system. That gives you essentially makes you unhealthy, weak, right, and gives you an increased susceptibility towards developing non-communicable diseases. Tobacco use. Smoking causes damage to walls of respiratory epithelium. So if the walls of the respiratory epithelium gets damaged, that's going to cause inflammation there, swelling and pain and so on, and resulting in diseases. Let me just write that down here. So once the walls of the respiratory epithelium get damaged, there's a couple of diseases that can occur. One of them is called chronic means slow, right? I've already explained this. Bronchitis. Remember bronchi, right? So anything itis is inflammation. Inflammation essentially is when you have a redness, warmth, swelling of an area. So chronic bronchitis would mean chronic swelling, or not swelling, inflammation of bronchi. That's one of the diseases that can occur due to smoking. Another disease that can occur is called emphysema. Emphysema, remember, the lungs is an elastic tissue, so you can easily expand and contract the lungs, but so you can easily exhale and inhale. But in emphysema, due to long-term smoking, the lungs would lose their elasticity, and that is emphysema. And together, if you have chronic bronchitis and emphysema at the same time, together that person is said to have chronic obstructive pulmonary disease. Okay? Cigarette smoke contains many carcinogens as well, so you would not only be at a risk of developing these diseases, which are very common amongst long-term smokers, as well as developing different kinds of cancers, not just lung cancer, but also something like liver and bladder cancer. Excessive alcohol consumption, regular and heavy drinking would also increase the risk of certain diseases. Obesity, being overweight or obese, increases insulin resistance, promoting diabetes. Remember, the hormone that decreases blood sugar is insulin. So if you are resistant to insulin, then you're not going to be able to decrease the blood sugar, which promotes diabetes. Excessive alcohol consumption, I want to talk about this again. Remember that alcohol is a poison, and we talked about in the circulatory system chapter a vein that links the small intestines to the liver, which is supposed to detoxify toxins. So if alcohol is a toxin, then you want to detoxify this, and that is done by the liver. So all the alcohol pretty much that we consume goes to the liver, and that can cause severe liver diseases such as liver failure, fibrosis of liver, as well as liver cancers. Genetic predisposition. Yeah, family history of certain diseases, for example, cardiovascular disease, hypertension, and even some cancers like breast cancer. Some people have the genetic predisposition to this. Environmental factors, exposure to pollutants, radiation, and harmful chemicals, right? If you're exposed to pollutants, for example, a lot of smoke and particulate matter, which you learn more in chemistry. Particulate matter are solid particles, very microsolid particles that are suspended in air, and these are released from burning fuel. So if you're exposed to different pollutants, it can lead to different non-communicable diseases. Okay? One kind of environmental factor that I really want to go into is ionizing radiation. We talked about this earlier as well. Basically, ionizing radiation is high energy electromagnetic waves. For example, ultraviolet rays, X-rays, gamma rays. Or they could also be radioactive decay particles. And you can refer to physics radioactive decay chapter, and if you really want to understand any of this, right, or any of the electromagnetic waves, just send us a message on WhatsApp and we can plan a lesson. Now, in either case, these can disturb the structure of DNA and can cause mutations. So if you have ionizing radiation, basically, remember DNA, right? Now, DNA is made up of genes, and if you're getting some harmful radiation onto this DNA, it can get damaged and mutated, resulting in different kinds of cancers. Let me elaborate on this a little bit because you've already understood the cell cycle. Remember the cell cycle, right? So you have a cell that has just been formed. It enters the stage 1, which is the interphase, in which it increases in cell size and increases its number of organelles, and most importantly, it replicates DNA. Then a signal comes in and it enters the next phase, which is the M phase, right? Stage 2, M phase. This one was the interphase. Now here's the thing. To go from this one to this one, right? You have a couple of genes that are involved that control the jumping from one phase to another, that determine whether the cell is eligible enough to be able to go to the next phase. For example, they check if the DNA has been replicated well or not, right? So if the DNA is well replicated, then after the signal, these genes will say, okay, everything is good, everything checks out, go ahead to the next phase. But if the DNA is not well replicated, then usually these genes will stop. These genes will stop the cell from dividing, stop the cell from jumping into the M phase, the mitosis or meiosis phase, mostly mitosis. Now, because of radiation or because of UV light, right, DNA gets damaged, and one of the genes that can become damaged is this one. So if these genes, which prevent the DNA from being, prevent a cell that has not replicated its DNA well enough to be able to go to the next phase, is mutated. So if these genes are mutated, right, then they're not going to function well. If they don't function well, then they're not going to stop the cell from dividing with errors. If there's errors in the DNA, they're not going to be able to stop it. So the cells with errors is just going to keep on dividing, and that's going to result in something called uncontrolled cell division. Okay? So the cell division becomes uncontrolled. Earlier it was controlled, but now you have a mutation in the gene that is supposed to control it. There's actually two types of genes. I want to mention this even though it's not mentioned in your book. So one kind of gene, which is this one, is called a tumor suppressor gene, right? That if this gene is present, then it prevents any tumor from developing by suppressing an incorrectly replicated DNA from progressing to the next phase. So tumor suppressor genes that prevent cell division, prevent unnecessary cell division. And then there's another one, oncogenes. Onco means cancer and genes. Oncogenes are the opposite of this. Instead of suppressing, they activate cell division. So either you could have a non-functioning of the tumor suppressor genes, or you can have a high functioning of the oncogenes. Either of these can result in uncontrolled cell division, right? If you're not able to suppress cell division, that's tumor suppressor genes, then you'll have uncontrolled cell division. Or if you have something that is stimulating cell division all the time, then you're going to have uncontrolled cell division, and that's oncogenes, okay? So very simple. So all in all, what you're going to get is uncontrolled cell division. Now, when you have uncontrolled cell division, you would have these cells that are suddenly dividing all of a sudden, right, and forming a mass. And that mass is called a tumor. Okay? So that's called a tumor. Now, tumors can be of two types. So one tumor is relatively harmless. It just exists as a mass and increases its size. Now, it may press on some structures in the body, but otherwise it doesn't really cause any harm. And that is called a benign tumor, okay? Mentioned later as well. So that's called a benign tumor. But sometimes the tumor that forms due to uncontrolled cell division is able to spread from one place to another, okay? If it is able to spread, then that's cancer. Ability to spread for a tumor, that's a cancerous tumor, also called a malignant tumor. So any agent that promotes cancer development, for example, alcohol, smoking, radiation, that is called a carcinogen. So carcinogens are materials that increase the risk of developing cancers. Okay, again, here's a picture that highlights some of the risk factors for non-communicable diseases. So we have a couple of genetic factors here, like family history, genetic inheritance, and so on. Environmental factors, like pollution, exposure to sunlight. Socio-demographic factors, like age, gender, race, ethnicity, education, and income, socioeconomic status. Factors of self-management, like how much they're using tobacco, right, COPD, chronic bronchitis, emphysema. Alcohol, like liver cancers and liver cirrhosis. Physical activity, like diabetes and coronary heart disease, right, person's weight, again, diabetes and coronary heart disease. Food choice, same thing, dental health care, and so on. Factors of medical conditions, medications, blood pressure, lipids, glucose, viruses, obesity, stress, etc. So all of these are risk factors for non-communicable diseases. Now, because you guys know what the risk factors are, hopefully you can guide yourself as well as those you care about around you to be able to take care of these, okay? Now, these different risk factors, how do we actually discover that these risk factors and anything else really is linked to a disease? And not just linked to a disease, but it is actually causing some mechanism to cause that disease. So those are two different things, right? Some relation that is called correlation, and the other thing is called causal mechanism. How do we discover the correlation first and causal mechanism? But of course, we will have to do research to it, right? We will have to look at some data and try to see if people are having this relation between a particular disease and a particular exposure, right? For example, people who are exposed to smoking are having chronic bronchitis or not, right? And we look at a lot of standard data, a large subset of data, and look that and observe that there is a higher incidence of chronic bronchitis in smokers than there is in non-smokers. So that is called correlation, right? That is called correlation. Now, to be able to prove that actually it is the smoking that is causing the disease instead of something else, we will have to do some research and find out the causal mechanism. Remember, correlation does not always mean causal causation, essentially. So to find out an agent link to any disease, data is gathered, right, and researches are performed. And so researchers may show a correlation between a disease and an exposure. For example, you could have something like chronic bronchitis with um, with smoking, or smoking with lung cancer. And then the correlation is further investigated to find out if it is actually causing the disease or not, or if there is some other causal mechanism. So remember, correlation doesn't always mean it's causing the disease. The mechanism that causes it would prove that it is. Okay? So here's an example of a particular data set. So increasing in age is the incidence of lung cancer by different groups. So for example, if you have smokers, right, they have the highest incidence. For example, over here we have the male who are current smokers. They have the highest cumulative incidence of cancer. Serious illnesses affect people, families, communities, and countries in terms of money and how they live together. So this is a very high yield point if you want to understand that there is a burden on economy if people are sick, right? So we want people to be healthy, not just for ethical purposes, but also because of economical purposes, especially for countries in the UK, countries in Europe, as well as inside the UK, because there is free healthcare. So if there is free healthcare, it comes from people's taxes. So if we try to minimize disease risk factors, then this will decrease the disease outcome. So if there's lesser people sick, then there's lesser burden on the economy, right? Saving money that can be used elsewhere. And yeah, so this is an important point, and this is usually this is a point that is mentioned in different answers for different reasons. For example, you could have a question like there's a scenario, and they give you a particular campaign that is reducing some risk factors, and they would ask you, what is the benefit of this, right? Maybe towards the country or towards us or whatever. And one of the benefits for that in your answer should be that it decreases the burden on the economy, right? Because there's lesser people sick. And yeah, so again, we go into cancers a little bit more. Basically, we repeat the things that I taught you about earlier. So here, so normally, without cancer, you have normal cell division, which is regulated from stage 1 to stage 2 to stage 3, and it is controlled by certain genes. Now, if there's mutations in those genes that regulate the cell cycle, then you're going to have uncontrolled cell division, right? There's no control on the cell division. And if you have a couple of cells that are uncontrollably dividing, forming a mass, then that is called a tumor. Now, tumors can either be benign. Benign tumors are those that do not spread or invade other tissues. Usually, when you look at their microscopically, when you look at them, they look similar to original tissue. So usually these are not a problem, and they can be removed if they are causing any symptoms. For example, if they become big enough that they're pressing on some structures, causing some pain or other symptoms, then you can remove them. Otherwise, they're relatively harmless. But the other types of tumors, and I want you to be familiar with this term now, are cancerous tumors, also called malignant tumors. Okay, malignant is the term that is used for a tumor that is cancerous, that has the ability to spread. And the act of spreading itself, and I want you to be familiar with this term as well, is called metastasis. So to be able to metastasize is to be able to spread from one another, and the act itself is called metastasis. So malignant tumors are those that have the ability to metastasize from one place to another. And on a microscope, they do not look similar to original tissue. They're very well different than the original tissue. For example, if somebody has let's say skin cancer, then the skin cells are going to look very, very different than the normal skin cells, and their orientation as well. Here's some x-rays of metastasis in the lung. So here's a normal lung for comparison. So below here, you see a normal lung with clear field, because there's supposed to be air here, and air is clear on the x-ray because air is not a dense thing. Bones are dense things that would block the electrons in the x-rays to give you a white precipitation here. But Air is clear, so it's not going to block anything. However, if somebody has a cancer in one place in the body and then they get liver metastasis, for example, lung metastasis, for example, somebody has liver cancer and it spreads to the lungs, right? Then you get these metastases that appear on the lung, okay? So what are some of the causes of cancer? Well, number one cause is mutations, right? Mutations in genes that increase cell division, for example, oncogenes, we've already talked about this, increasing their function. Or mutations in genes that decrease cell division, like tumor suppressor genes, decreasing their function. So either you increase the gene's function that cause cell division, or you decrease the gene's function that suppress cell division. Now, mutations can either be spontaneous, so they can just occur on their own. For example, cells that are dividing by themselves, right, on their own during cell division, they can develop these mutations. And usually, they will be stopped by mechanisms that prevent the cell from going from one phase to another if they have errors or mutations in their DNA. But this can occur by chance that the cells are allowed to progress, resulting in cancers. We actually make cancer cells pretty much every day, but they either commit suicide because they are checked, right? So as soon as they get a mutation, the DNA is double checked, and the cell realizes, okay, that's a mutated DNA, and we gotta take one for the team, right? We gotta commit suicide because this is not good. So committing a cell, basically killing itself in a regulated manner, is called apoptosis, in which the cell pops itself, right, in a regulated manner. Or they can again be killed by T killer cells. Remember T killer cells, right? They are the ones that kill virally infected cells and cancer cells. So T killer cells are also able to kill the cancer cells. Sometimes a cell can escape this killing, and if it escapes, then it results in cancer, right? Carcinogenic. Mutations can also be carcinogenic, for example, that come from carcinogens. And we just talked about what carcinogens are. These are materials that can mutate the DNA. For example, smoking is carcinogenic, UV light, X-rays, CT scans, radon gas, nuclear radiation, and alcohol. Now, during viral infections, some viral infections can also mutate the DNA. And not just viral infections. Viral infection can mutate DNA, but some bacterial infections. Like there's a popular one, I'm going to tell you this. You don't have to remember this, but there's something called, a very popular one that affects the stomach. It's called Helicobacter pylori. Okay? And basically it's a very common bacteria that causes stomach ulcers. Stomach ulcers are those things that ulcers are basically manifestations of a disease in which the stomach wall is eroded. So if stomach wall is eroded, then you've got all of the stomach acid going into the wall and causing a lot of pain. So Helicobacter pylori can result in gastric cancer, stomach cancer, and you could also have viruses that can directly mutate DNA, like human papillomavirus. This is the most common cause of cervical cancer in females. So basically when it affects females, it can cause mutations in the cervix, which is an organ in the reproductive tract, leading to cervical cancer. And so basically, teenagers in the UK are routinely vaccinated against HPV to prevent this from happening, okay? Usually, basically what you would see on a clinic is that you get a female, maybe in their 40s, something like that, and they got a viral infection maybe 20 years ago, right? And now it affected some cells and damaged them, and then over time it has developed into this cancer. Now here's the thing, it's the only cancer that comes with a vaccine, right? So if you just get vaccinated for HPV, you can just eliminate your chances of developing this, right? So all females are recommended to have this vaccination. So what is the treatment for cancer? Well, number one, you got to remove the tumor, right? You got to remove the cancer itself. So that's surgery. If the cancer is not removable, then you just do other methods. Otherwise, you just try to remove the cancer and then do the other methods. Now, if the cancer has spread, usually you would get chemotherapy. Chemo means chemicals, and therapy means basically treatment, right? So drug treatment is that you have drugs that target those cells that are rapidly dividing. You have to understand this. Cells that are rapidly dividing, only those are targeted. So therefore, these drugs are not going to go and target every single cell in the body and try to kill them. No, it only targets those cells that are rapidly dividing. So any of the normal cells in the body that are rapidly dividing would also be killed. For example, hair cells, right, and intestinal cells. Remember, hair is actually formed of cells. Intestinal cells causing hair loss and vomiting as side effects. So if you don't have hair cells, or if you don't have intestinal cells, that can result in a lot of gastrointestinal problems as well as hair problems. And lastly, we have radiation therapy. Radiation therapy is that you send X-rays or gamma rays. Again, X-rays and gamma rays are covered more in detail in GCSE physics. These are launched at cancer cells. And remember that these are ionizing radiation. So these can mutate the cancer cells. Now here's the thing. When they mutate cancer cells are weak, right? They're not able to protect themselves. And they're not able to repair the damage. So cancer cells will easily die. Normal cells, they survive. Usually, because they are strong enough to handle mutations. So it's kind of like you're sending the radiation, normal cells are strong, cancer cells are weak. Cancer cells die, normal cells live. Okay? Well, there is a slight chance that a nearby normal cell can become cancerous as a result of that treatment, but that would happen in the distant future, not immediate. Okay? And that's really it for the cancer. So here's cancer cells forming, cancer securing its host, cancer killing its host, and cancer also killing itself. After killing the host, cancer kills itself. Okay, and next up we have smoking and its harms. Okay, so we have understood that smoking is bad for us. But why do people smoke in the first place? People smoke because it contains something called nicotine. Nicotine is an addictive chemical that gives a feeling of well-being, right? It gives a feeling of reward. And so that is why people are addicted to this chemical. And if they try to find some other means of getting nicotine, they'll also try to do this. For example, nowadays you have nicotine pouches and vaping, e-cigarettes, and so on. So nicotine, it also increases blood pressure and heart rate temporarily. Nicotine is relatively less harmful than other things that are found in cigarette smoke. So other things that are found in the cigarette smoke include carbon monoxide, other carcinogens, particulates, and teratogens. Let me just quickly draw the respiratory tract here. So remember that we had the trachea, right? And the trachea was dividing into the bronchi, and then you would have the lungs over there. Okay, so the trachea, which had these C-shaped rings of cartilage, had these cells here, right, on the walls. So let's have a look at the cells of the walls of the trachea. So here we had the ciliated cells, right? And the other type of cells that we had were goblet cells. So we also had goblet cells here, which were secreting this mucus. And this mucus was being circulated by the cilia up towards the throat, which was being swallowed. Now, if you have smoke coming in, right, smoke coming in, it is going to directly damage all of these cells, okay? And it's going to increase the number of goblet cells. So you're going to be producing a lot of mucus. So you're going to have a lot of goblet cells and relatively less ciliated cells, which means that there's a lot of mucus here. That's number one. Number two, when you're damaging these cells, that's going to cause inflammation. So you have this chronic inflammation going on here as well. So a lot of coughing to get rid of the mucus, chronic cough, chronic inflammation, right, resulting in the disease that we call chronic bronchitis. On top of this, when the lungs lose their elasticity as smoke goes into the deeper portions of the lung over time, then as the lungs lose elasticity, then that is also called emphysema. And together, they give you chronic obstructive pulmonary disease. Now, these are in more detail mentioned in other words. So, number one, we have the smoke, the particulate matter. Number two, we have the tar, right? So that's number one. Number two is we have tar. So tar is a blackish substance that deposits on the walls of the trachea. and the bronchi and the lungs, essentially. So throughout the lung, you'd have a black colored substance that is deposited. Now, tar also stimulates coughing, so you're going to have cough. And tar is a carcinogen, so it's going to increase the risk of cancers as well. So that is also really, really bad. And then number 3 is nicotine. So remember, nicotine is the reason why people smoke most of the time. This gives you, essentially it diffuses into the brain somehow through the blood, and then what it does is that it gives the person a feeling of well-being, right? A feeling of reward, a feeling of happiness. It calms them down as well. So it increases the feeling of, it increases essentially euphoria, right? It has some euphoric effects. However, as on a long-term use, actually, you get more and more dependent on this, and you need more and more nicotine to get the same effect. And so people are smoking for a very, very excessive amount, maybe multiple packs a day, right? Or even a whole pack a day is a lot, and people smoking multiple packs a day is just too much. So nicotine increases the euphoric effects, which basically means gives a feeling of happiness, well-being, right? Reduces anxiety, and so on. However, on long-term use, this can also have some really bad effects, like nicotine can cause depression and stuff. But on top of this, nicotine increases blood pressure momentarily, okay? And it increases heart rate. And some research has proved that nicotine is related to some heart problems, okay? Like coronary heart disease as well. Now, the fourth thing in the smoke is carbon monoxide. Carbon monoxide, remember when we were doing the red blood cells, I told you that in hemoglobin, normally it binds oxygen, but sometimes carbon monoxide, which is a poisonous, colorless, odorless gas, so carbon monoxide is colorless, right? Odorless gas that binds irreversibly, permanently to hemoglobin. So it binds hemoglobin, then you're not going to be able to carry oxygen, which means that you have a lesser chance of producing energy, and if too much of carbon monoxide builds up in your blood, then the person can potentially die, okay? So that is also a toxin. Okay, so let's review this very quickly. So carbon monoxide, cigarette smoke contains carbon monoxide. This can more preferentially bind to hemoglobin than oxygen. So if hemoglobin has a choice between carbon monoxide and oxygen, surprisingly, it will bind carbon monoxide instead of oxygen. On top of this, it irreversibly binds. So this results in a decreased ability of hemoglobin to carry oxygen. Now, in pregnancy, this can be obviously disastrous because you have a baby that is living in the fetus, in the placenta, and so if you're not able to get the oxygen through the placenta to the womb, to the fetus, then that's going to result in declining of development of the baby, right? The baby will have some birth defects, baby could have a intrauterine growth restriction. Teratogens. These cause birth defects. Teratogens are all those agents. This is a fancy word for basically something that will cause birth defects. So a cigarette smoke, of course, is known to cause birth defects, so that's also a teratogen. But you have many different teratogens. Alcohol is a teratogen. What else? We have a lot of drugs are teratogens, like some anxiety medications are teratogens, some depression medications are teratogens, etc. Okay? So teratogens cause birth defects. Teratogen stands for a particle that can cause birth defects, and smoking is teratogenic, right? And some drugs, alcohol, etc. As it can cause birth defects not only by decreasing oxygen supply, but also directly through harmful molecules that can harm the fetus. Number 3, a cigarette would contain carcinogens, for example, tar and a lot of other carcinogens. Actually, a cigarette smoke contains over 70 carcinogens. So smoking will directly damage the ciliated epithelium as well, right? So mucus cannot be removed. But on top of the damage to the respiratory lining that can lead to cancer, it also contains tar and 70 other carcinogens. So they can also lead to mutations in the cells, not just in the lungs, right? That's where it's going, but not just in the lungs. A lot of this stuff can eventually go into your blood, and from the blood, it is filtered by the kidneys into the urinary bladder. And occasionally, it can accumulate in the urinary bladder, causing bladder cancer. Particulates. Particulates are basically small molecules. The particulates causing inflammation in bronchi. Bronchi and bronchioles can become inflamed, causing a condition known as chronic bronchitis, which we have just looked at. So if you have particulates coming from cigarette smoke, they're just directly damaging those ciliated cells. This is characterized by repeated coughing up of mucus, and this inflammation can further damage the lungs, decreasing their elasticity, and that is called emphysema. So both chronic bronchitis and emphysema together are known as chronic obstructive pulmonary disease. And COPD is one of the most common conditions in long-term smokers. Okay? What about role of diet and exercise in disease development? So we have elaborated on this a little bit. Let's have a look at more details on this. So role of diet and exercise in disease development. Your weight, exercise habits impact your chances of getting different diseases, some of which can change or even end your life. Eating too much will make you obese, right? And obesity is a major risk factor for a lot of different diseases. For example, heart disease, coronary heart disease, type 2 diabetes, high blood pressure, etc. So, how does obesity impact? Well, obesity, or being overweight due to poor diet, increases insulin resistance. Remember, if you're resistant to insulin is the hormone that decreases blood sugar. So if you're resistant to insulin, then you're not going to be able to decrease the blood sugar, right? So if you cannot decrease blood sugar, your blood sugar is going to be always high, right? And that is called type 2 diabetes. There's 2 types of diabetes, and one of them is this one. Number 2, increases chance of lipid deposits in blood vessels, increasing the risk of coronary heart disease. Remember, coronary heart disease is when lipid plaques like cholesterol deposits and fatty plaques build up in your coronary arteries that are supplying the muscle of the heart. So if lipid deposits build up in the coronary arteries, you're going to have coronary heart disease. And that is another risk factor of poor diet, obesity. Eat less food, do more exercise. That was Piers Morgan on Good Morning Britain. I guess some body-positive obese individuals. This is a very famous clip, very viral on YouTube and Instagram. And this is a very famous quote that I've quoted from Piers Morgan. What's BMI? BMI, essentially, and I think as an educated individual, you should know what BMI is. I haven't seen a question directly on BMI, but it is mentioned in your book, and as educated individuals, one should really know what a BMI is. So BMI is essentially measuring or classifying people according to their weight, right? It's a method of classifying people according to their weight, their height. Some people are healthy, right? Some people are a little bit overweight, some people are obese, and so on. So BMI is calculated by dividing weight in kilograms by height in meters squared. So it's very easy. Basically, you have weight, right? kg over meter square height, right? And you get a couple of different types of BMIs. For example, you could have something like 18, 20, right? My BMI is, I think, 20 or 21. And then you could have 25, right? And 30. 30 or more is obese. So it is calculated by dividing weight in kilograms by height in meters squared, with ranges classified as underweight, which is less than 18.5, normal weight, which is 18.5 to 24.9, overweight, which is 25 to 29.99999, and obese, which is greater than 30. Now, maybe you guys can go on the internet or do it by yourself using a calculator. Try to find out what your BMI is. And lastly, we have alcohol, right? Alcohol is also part of our diet. So alcohol, ethanol. Ethanol, by the way, its formula you learned in organic chemistry is C2H5OH. Yeah? Ethanol is a social drug. When drunk, ethanol passes through blood and goes into the brain. What it does is that it is able to delay nerve impulses, slowing down your brain, slowing down your reflexes and thought processes, and this should be taught, and essentially just making you get rid of any worries and any anxiety and all those things. So ethanol is usually detoxified by the liver before it causes permanent damage, because remember, the detoxification center of the body is the liver. So if it is always going to the liver, right, it can cause damage to the liver, and one of them is called liver cirrhosis. Cirrhosis essentially is just normal liver tissue, which is normal liver cells, being replaced by a fibrous tissue, and that is called liver cirrhosis, also called liver fibrosis. The normal liver tissue is replaced by fibrous tissue, leading to liver failure. Number 2, you have cancers. Of course, you're constantly damaging these cells, and these cells have to divide all the time. And so constant damage and division can eventually lead to different types of cancers. For example, liver cancer, because you're damaging liver all the time. Mouth cancer and throat cancer as well, because it's going through the mouth and through the throat. Because remember, alcohol is a very big carcinogen. So very bad for health, really. There's no point of drinking alcohol if you're an educated individual. Number 3, permanent damage. Chronic long-term exposure can cause irreversible brain damage. This is really, really bad, and occasionally on clinics we see people with this. They have this confusion going on, they have this weird movement with their eyes, and they cannot remember anything, and they cannot even form new memories occasionally. And so that can result in permanent brain damage. Birth defects. Alcohol is a teratogen, right? We've already talked about this. What is a teratogen? A teratogen is any agent that causes a birth defect. So it passes through the placenta to the developing fetus, promoting miscarriages, stillbirths, birth defects, right? Many different kinds of birth defects. And yeah, so that concludes our chapter on non-communicable diseases. To end this, we have a meme. Not sure if hungover or dying. So again, I cannot emphasize this enough, but like smoking, medically speaking, alcohol is really, 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 really bad. Okay? By the way, here's a fun fact. According to himself, Donald Trump, the former president of the US and probably going to become a new president now, has never smoked or drunk. And he is 78 years old. Okay, so I have a question for you guys, and I want you guys to research this if you have to. What are the 3 or more common symptoms of COPD? At least give me 3, okay? And please code your nicknames and question with your answers so that I can keep up with your progress, okay? And yeah, that's it for this video. So thank you so much for watching, and make sure to like and subscribe. And if you need to book some lessons, just give us a message on the WhatsApp link provided below, okay? I'll see you in the next one.